So first, I'm gonna choose a short, about 5-second clip that has a ball handler in it. Then I'm gonna click yes to save the debug overlay. That just returns the raw data that comes from the inference layer. And I'll start the job. Once the job is done, you can see that the inferred ball handler is surrounded by a bounding box with their approximate foot position marked with a green circle. You can also see on the right side that the approximate position of the ball handler is marked on a top-down representation of the chords. There are also options to select or deselect the bounding box, show or hide the foot marker as well. You can also hover over the bounding box to see more details about where the player is on the court, and you'll see soon enough their percentages from that position on the court, depending on the radius that you set. So now I'm going to select Stephen Curry from the NBA API. I'm going to select a season, and then I'm going to filter by minimum attempts and shot radius. I'll keep those at the defaults for now. So as you can see, Stephen Curry hits 46% of his shots from that area of the court within a 5-foot radius. And you can mess around with the radius and the minimum attempt numbers just to see what you get. So here you can see the numbers being fetched in real time based on the approximate or the estimated position of Stephen Curry on the court, which is pretty nice to see. So I can also change the year, the season, so you can see what, for example, what 2018-19 Steph would have scored from that point on the court. It's a little lower than 26 Steph, 44%. Here you can see the raw data that comes back from the inference, all the frames and the options of whether the ball was detected, whether the player was detected, the confidence, and the position, the foot position of the detected player. This is just for the possession, so it only shows data regarding the player that has possession of the ball, if there's a player that has possession of the ball in the frame. And here is the output that comes from the inference layer directly. You can see the mapping of the court, the ball handler, the ball, and the other players on the court. And as you can see, there are some issues with short boxes on partially occluded players, like number 8 on the Warriors. There's a guy on the sidelines that is covering the bottom half of his legs, so the box stops short of where it's supposed to be. So if a player took a shot from that spot, the program would show the shot being taken from inside the arc when it's probably not. So those are some things that I'm still working on. So let's try a different clip. Let's use Wembanyama. And this time the basket is on the right side, so I would change that option and leave everything else as default. And then I'm going to start the processing. This doesn't take too long, maybe less than 15 seconds, I think. I'm just going to let it run. And just like that, it's done. And as you can see, the issue I was mentioning before with the shortened box around occluded players. So if Wemby was to take a shot from that position, it would mark as inside the arc. But besides that, everything looks good. Easy step back 3-pointer for Wemby. And let's search for Wembanyama. And this is also from 26 season in the playoffs. going to leave everything else as default, and you can see a little bit of a false read there because it thinks it's inside the arc, 38% from that spot. Going to reduce the minimum attempts so it can get more data. 50% from that spot, only 2 attempts though. No, you would say that's a pretty bad shot, but I guess Wembanyama got lucky on this one. 21% usually. That's with a 5 foot radius though, so it's probably worse if I narrowed down the shot radius. Another interesting thing is you can change the player and see, for example, what Stephen Curry, a 22 playoffs version of Stephen Curry would shoot from that position as well. So if you swapped Wemby with Steph, he would hit 36% from that spot, which is still not very good, but I'm sure the defense would hate having Steph over Wemby shooting that shot. Here I'm just messing around with different years of Steph and seeing what he'd hit instead of Wemby. But yeah, that's just another way to use this program. This example is going to show some of the limitations of this program at the moment, because this clip involves a pass and a lot of occluded players or partially occluded players. So I'm just going to start the processing for this one. And we'll go straight into the debug overlay. And you can see Wiggins, Tatum, Steph, Looney, everybody is partially occluded, and the program is having trouble drawing the boxes around the players and finding the proper ball handler, because the ball handler is calculated by proximity of the ball to the player. So right here, I got lucky. Steph is fully free, and the bounding box is correct for him. But you can see where issues might arise with my current method of doing this. And here in the program, you can see, yeah, Wiggins, the bounding box for Wiggins is not good. The one for Steph is good, at least when he catches the ball. Yeah, when he catches the ball, it looks good. But Wiggins, the passer, the bounding box was not good. So I need to go back to the drawing board and figure out how I can improve the inference. Hopefully I don't have to retrain anything. I think it's just a matter of rethinking my approach to this program, because right now everything is calculated on a frame by frame basis, and I think introducing some type of motion specific training model should help a lot instead of doing everything frame by frame. I think there are better ways to do this player detection. So I'll go back to the drawing board with that, but this just serves as a quick demo of the software as it is right now. Thank you for watching the video. If you want me to go over the code, I can do that as well. I'll also work to deploy a Docker container that people can run easily on their machines that has all the code and, of course, the software and models ready to go.